won't see us. So, hi, I'm Daniel Bogdanoff, streaming live from Keysight in Colorado Springs. Each weekday until March 15th, we'll have a new test gear tip and draw the day's winners. Today we have 11 winners. And remember, you can sign up at wavekeysight.com and get a new entry each day. All entries are included in all drawings, so you don't have to sign up every day, but the extra chances to win, they definitely never hurt. By registering, you also get access to the Wave libraries, which are full of hand-picked ebooks and app notes. I'd love to know in chat or the comments which of those has been your favorite so far. Today we're live streaming so that we can do some Q&A at the end of the stream for those of you tuning in live. For the folks that are watching after the fact, we still have 2 more live streams coming up on Monday, March 11th and Friday, March 15th, and we'll do some Q&A at the end of each of those. We had a panel Q&A on Friday, and we didn't get to all the questions before we ran out of time, so I'll be happy to take on some of those today. We'll also start with a quick test gear tip and then draw the names of today's 11 winners. Each weekday, we're giving away one DSOX 1204G, that's a 200 megahertz scope, a bench view license with all the software options. We're going to give away 2 of these U1233A 3.5-digit handheld DMMs and 2 200 megahertz oscilloscope probe 2-packs. We also have some bonus prizes that change each day. Today we're going to give away 5 U1282 4.5-digit handheld multimeters, and those are a few $100 each, and I use mine all the time. And tomorrow we're giving away 3 1 gigahertz 3000T touchscreen oscilloscopes, so those are really exciting. Those are some of the bigger prizes that we're giving away, so tune in tomorrow to see who won those. Before we give away today's prizes, we are going to have our our only test gear tip of the day with Bill, our resident power expert, and he's going to walk us through how to test your design's power supply transient response using an E-load. Many electronic devices pull current in bursts, which can cause a dip in the power supply's output voltage, and this is known as a transient response. It's kind of like how the lights flicker in some older buildings when the fridge or AC turns on. A transient response test measures how fast the power supply can recover from a change in load. This load can be anything, something big like a motor or something seemingly innocuous like bits changing on a bus. Let's take a look. If your designs use power supplies, and most of yours probably do, you need to make sure the transients aren't going to cause performance issues. There's a lot of homegrown options out there, but the industry standard and best practice is to use an electronic load. Electronic loads are more than just resistor banks and are designed to avoid adding unwanted ringing or noise. So let's test run a transient test on this power supply using the load module that Bill brought along. By the way, this load is brand new. It just came out in February and fits inside one of the power analyzer slots. This specific E-load has several built-in waveforms, along with the ability to create a custom arbitrary waveform. We can use these waveforms to create dynamic current loads for specific tests that you want to run on your device. Bill, can you walk us through the tests that we're going to run today?
Absolutely. We're going to test this power supply for the worst-case transient response. And to do that, we're going to use our new E-load module. And we have it set up so we have the power supply at its max voltage. And right now it's drawing only 50% of its max current. But we're going to use the E-load to ramp it up to its max current, and that's going to create a transient, which we're going to be able to measure on the oscilloscope.
So right now we're sitting at 50% current draw, basically 50% of spec for this power supply. We're going to shoot it up to 100% and see how the supply responds.
Correct.
And we'll expect to see a little bit of dip, which is normal, but we want to make sure that that dip is in spec and that it's not going to break our designs later on.
Correct. In fact, this power supply can recover within 50 microseconds.
Awesome.
So that's what we're going to look for today, see if we can do that.
Sounds good. So we have our E-load set up. Can you show us the waveform that we have going here?
Absolutely.
Talk through it.
We have a pulse waveform set up, and what's really nice about these built-in waveforms is to create the pulse, we only need to set 5 parameters, 3 of which are the timing of the pulse, and 2 are the current settings, the low current setting and then the high current setting. And so with that, we're ready to go. We just need to run our arb.
So we have 2.5 amps up to 5 amps, and we're running it at max voltage. We also have a scope set up so we can see that transient response.
Right.
Now there's a couple options for looking at that response. We're using a scope. What are some other options that people might have?
This does have a built-in measurement system in it, and so for slower waveforms, it works great. For this particular waveform, the oscilloscope gives us a little bit bigger display. We have the measurement marker, so it makes it a little bit easier.
Okay, great. So let's set it up and run it.
All right, well first we'll start with a single trigger on our oscilloscope, and then we'll run our arb. And as you can see, this is our transient response. And so I've set the markers on the vertical to show 15 millivolts. So when the power supply recovers to within 15 millivolts, it's considered recovered.
So our vertical markers here, we can see it's a little bit slightly lower, but it's well within spec. So on the left side, we were sitting at our normal voltage. It came back up slightly lower, but well within the boundary of what we'd expect.
Yeah, typically on power supplies, we don't spec how far it's going to dip, but what we're looking for is for that recovery. So we want it to come back within 15 millivolts, and that's what the two markers show on the vertical, and the horizontals are timing. And so
here.
And our timing, the spec is 50 microseconds. I think we're at about 30 microseconds.
Yeah, so delta X there is 25.4 microseconds.
Wow, about half.
So it's obviously performed swimmingly. So this power supply should be good to go for testing whatever we need to test. So what's our takeaway here?
The new load makes it really easy to do dynamic testing of power supplies. And so as an example, we did a transient response test, and it was really easy to set up, and we were able to get the results we expected.
Awesome. So I apologize if that volume started pretty hot. We were kind of scrambling with the audio settings before we started today. If you want to keep getting technical today, make sure to check out the Wave libraries over on the Wave homepage. You can just scroll down, and we have some hand-picked app notes and ebooks around each of the product categories that we're giving away. But now let's draw some winners, and after that we'll do some Q&A, so put your questions in the chat and we'll get to those Q&A questions. I'm going to go ahead and draw today's winners. And today's winners, the first winner wins a DSOX1204G. That is a 4-channel, 200 megahertz oscilloscope with the built-in waveform generator. That winner is Michael Hobhuber. Congratulations, Michael. The winner of the BenchView license, that's a perpetual, all the goodies BenchView license, is Jack Brandt. The winners, 2 winners of the U1233A handheld DMMs, these are great little DMMs, is Abdurrahman Desai and Felix Pohl. Congratulations, Felix and Abdurrahman. You will win a U1233A. Next, we have the 200 megahertz probe 2-packs. So those are 2, they're also, I think they're switchable, 10-to-1 attenuation. They're pretty nice. We have William Bell and Aki Anguervo. Congratulations. We'll be in touch with you also. And the winners of the U1282A, that's kind of the bigger, fancier handheld digital multimeter. We have 5 of them today, is Jan Legenstroth, James Krugnall, Ryan Thornburg, Stefan Brenner, and Martin Jungworth. Congratulations to all of you. We will be in touch in the next 48 hours, so check your email inbox for those. There's also a web page where we list out the winners if you have, if you want to go see who the previous day's winners were. But we also, you can go check out the videos and see the tech tips for each day. So now we're going to do some Q&A. So I'm going to hop down here, and I'm going to pull up the chat window. And if you put questions in chat already, some of those have been sent to me. Let's go ahead and start. Someone says, ew, there's sound. All right. So let's see some of the questions. Let's see what we have. And remember, we had the panel Q&A last time, so you can also check those out. We avoided some of the more like application specific questions and scope specific questions in the interest of time, but we're happy to take those today. So let's go ahead and take some of those. All right, questions in chat. Someone says they're scared to turn the sound up. We're not going to play with the sound anymore. Let's see, can you add modulation with the built-in waveform generator? Yeah, let's pull that up. I'm going to move my computer out of the way, and I'm going to pull the scope in, and we can just keep that close-up shot going. If we can pop back into that close-up, I'll get this all queued up. And in the waveform generator menu, I don't know if that's close enough for you to see, but yes, you can add it. There's a settings on the bottom and then modulation. So you can do AM modulation, FSK modulation, and FM modulation. So the difference between those, AM modulation, it starts, AM is amplitude modulation like AM radio. FM modulation, it modifies the frequency based on your input. And here we have a close-up. And then FSK modulation is more, it's called frequency shift keying. And instead of following like a sinusoidal I don't have a BNC, otherwise I'd show it. Instead of following like a sinusoidal or a ramp pattern in that frequency, it just shifts like a 1 or a 0, so you can essentially send digital bits 1 or 0 based on the frequency that's set up. So those are the 3 schemes you have in all of the InfiniVision scopes that have the built-in waveform generator. So if you get a G model of the 1000s, it has the waveform generator. If you get like the 3000T comes with it automatically. The 4000X and the 6000X have 2 of them each. I'm looking at the wrong camera. So you can get those in all kinds of InfiniVision scopes. Do these meters do logging? This one, the U1233A, does not do logging, but the U1282A, I believe, does. And there's also like a Bluetooth module. This one has it too if we pop to the close-up. There's a Bluetooth module that connects in the back here. So you can like connect it up there, and you can actually log like on your phone and stuff with an app. So yes, you can do logging on the DMM. Does the new DSO 1204A on your bench do FRA in the version without the gen out? You have to have the waveform generator to do the FRA. So only the G options, and it comes with that standard, is that right? Yes, it comes standard with the G models. It does not come standard with the non-G models because you have to have both the source and the input to make that happen. Otherwise, you can try and work something out with like a function generator or something, but the built-in app, you have to have the waveform generator. Can you upgrade the bandwidth? Yes, so all of these have one model number. All of the InfiniVision scopes are bandwidth upgradable, so you can do that in hardware, you can do it in software. It kind of depends on the jump. These are all essentially under the hood, 200 megahertz, and they come starting at 70, and you can upgrade them with software up to 200 megahertz. What else? Let's see. Okay, I'm going to check the chat here. Can it play Doom? Someone actually just hacked it to play Doom if you search on one of these, I think. It was either this one or the 2-channel 1000X. Someone broke into the OS and got it playing Doom. So yes, it does play Doom. What else? Someone asking what the big DMM was called. So there's a bigger handheld. It's like the U1282A. U1282A. I have one at my desk, but it's not in this room. I should have brought it in. They're great. I love those. Let's see. Are oscilloscopes battery powered? So there are some handheld oscilloscopes out there. Usually the people who are using battery powered oscilloscopes are doing like field testing. So they drive a company truck out to the site and do whatever in the field. Most scopes, especially as you get to like higher bandwidth and more capabilities, scopes are going to be powered. There are some options out there for ways that you could, hook up. Like there's some like battery powered AC adapter units that if you really wanted like a test cart to roll out to test a jet or something, I've seen that. Then you could get it battery powered that way, but they don't usually come battery powered standard. Are there FPGAs inside your scopes, and with which FPGA vendor do you cooperate? So yes, we have I think probably a couple FPGAs inside of these. I know we definitely do on the bigger ones. It kind of just like any FPGA choice, the R&D teams really dig in and decide which FPGA is the best price performance. So it has to be able to do what they need it to do, but it can't cost too much. So you kind of have to evaluate vendors for FPGAs based on your specific needs. I know Dave Jones has done a couple teardowns on these scopes and goes into some of that, so you can check that video out. I don't know that he's torn down a 1204 yet. I know he has one, so you should hit him up, make sure he's planning on doing a teardown of it. He did tear down the 2-channel version of the 1000X and talk through some of that, so you can check out that video as well. Let's see, battery, yeah, that's someone else mentioned, don't forget battery-powered scopes are completely isolated. That is something that you get, so this ground part of the BNC on the channel is actually connected to the ground, so it's not necessarily isolated from the grid, so some people do like battery-powered options for, to get the isolated channels. There's a lot of other options there. And a fun little, bonus tip, best practice, we might even make this a tip of the day later, in Wave is one of the things is when we see people have blown up their scopes, they take a scope on a cart and they roll it over somewhere and go to hook something up and it shocks it and they blow their front end. One of the best practices that you can do is just touch the ground portion of the BNC or the SMA connector and essentially ground yourself before you ever hook up any probe or anything. And that's a really easy way to protect your system without like using an ESD strap or an ESD code or any of that stuff. That's just kind of it's a good best practice to have. Let's see. So it's an oscilloscope, signal analyzer, and signal generator all in one device. We could do it, but you probably don't want to pay for it. We can do a lot of things, and we have the hardware around to do that all, but every capability you add builds in a cost to the instrument. So it's kind of finding that balance between, just like the FPGAs, it's that price-performance play that our designers have to make every day. Yeah, logic analyzers. So someone asked about MSO or logic analyzers. The 1000s don't have an MSO setup. The 2-channel has like a trigger import that you can use as a 1 digital channel. Once you get to the 2000, 3000, 4000, 6000 and up, then you start getting the MSO capabilities. Let me see if I have one behind me. I'm going to pull one up real quick. I'm not going to plug it in, but on the 3000T, for example, if we pop to that close-up shot, you can hook up digital, angle it a little bit. You can hook up digital channels in right here, and you get 16 digital channels, and you can do decoding and that type of thing on them. What else do we have? Where's the USB port? That was Electro Tombs. There's a couple on the back of the 1000X. This one has them. There's one in front, and then there's a couple in back. There's both a host and so you could, printers, that type of thing, and then a device USB. And then the 1000, also, it has, we pop up to the close again. There's a device in front, and then a host. Woo, there we go. A host in back there. And LAN, built-in LAN's always pretty nice. What else do we have? Can I talk? Let me think about if I want to answer this. Can we talk a bit about warranty and coverature? Yeah, so pretty much everything you buy new, and one of the benefits of buying new gear from a vendor or even like factory refurbished, like from our eBay store or something like that, is they come with a really, really comprehensive factory warranty that pretty much covers anything. You can also buy extended warranties for them, and they pretty much cover all the goodies and anything that could go wrong on them. After that warranty period, repairs start to get more expensive because when you send these in, the same person repairing this scope is the person that's also repairing like the 110 gigahertz UXR. So there's that trade-off of like the warranty is really nice if something goes wrong, and then after the warranty it can get more costly, but it's always better to have a working scope than to not have a working scope. Someone's asking what they can do over Ethernet. So you can actually do a full remote control. So you pull up in an HTML5 browser. I don't think we use JavaScript anymore. It's been a minute for me. It pops up an applet that looks just like the scope. So you can use all the buttons. You can save screenshots. You can also, if you don't want to use that GUI, you can use like the Skippy command infrastructure. There's a programmer's guide online that lists out all of the programs you can use. Essentially, and you can kind of think of it like this, anytime a button's pressed, there's a command being sent to the scope. So you can also emulate that command with a Skippy command, SCPI, and do all kinds of stuff programmatically over internet. You can also do that over USB using BenchView, which will come with the scope if you win it. Is there a rule of thumb for picking what memory depth to use for a given signal? So there's kind of a trade-off. The InfiniVision scopes use all the memory all the time. And there's an ASIC designed to handle that load. A lot of scopes use a processor-based architecture instead of an ASIC processor-based architecture. And when you get to that non-ASIC processor, the more memory you use, it starts to load the scope down and slow down the waveform update rate. So you kind of have to tailor on those scopes the memory depth to get the performance you want. With Infinivision scopes, you don't have to worry about that. It just uses all the memory all the time. If you're doing like deep traces, that type of thing, then you can usually handle longer memory in a laggier scope, but you kind of just have to play with it and figure out what works for you. What else? X, Y, Z behavior. Can you get, so X, Y mode is a different mode than just the standard normal or triggering exhibition mode. So a normal scope has, X is time, the X-axis is time, and the Y-axis is voltage. In XY mode or XYZ mode, you have channel 1 is the X-axis and channel 2 usually is the Y-axis. And you get this like amplitude plot. And you can actually tell the phase relationship between two different channels. Last year during scope month, we did one of the tip of the days covered XY mode, so you can go check that one out. If you search our videos, that should pop up. And then XYZ mode is a little different, where Z mode kind of acts like a camera shutter, and it tells you when to capture. So this is used a lot in manufacturing, or if you're trying to just kind of get a quick snapshot of the phase relationship between two signals. So they work pretty well. It's kind of a corner case or a kind of a cool case, if that makes sense. So most people don't use that mode. It does exist in these scopes. Someone, Abusive Ben, I don't know why I read that username, but it says, hello Keysight, I just want to say thank you for doing these giveaways and getting the younger generation excited about electrical engineering and repair. You've watched many of our videos. Awesome, thank you, we love that feedback. Do you have a 240 volt scope? So I think the question is, do we have scopes that run on 240? We use, let's get to the close-up again, if I can get my wires untangled. One of the things we do with these scopes, I don't know how easy that is to read here, is we use a universal power supply, so it kind of works with a broad range of power inputs and frequencies. So this one does take a 240, I'm gonna have to bend over to see it, 240 volt, 50 or 60 hertz input. So you could run this if you wanted off of like 220, I guess. If that's what your country does. I recommend using your country's standard input and not something crazy. Just for the record, but it's spec'd in there. I would also check the data sheet and make sure that the power supply specs match the power source that you're using. That's all listed and specified out with tolerances in the data sheet. Is there a way to do user-defined protocol? We don't do user-defined protocol decoding. I don't know of any scopes out there on the market that do that. I've been pushing for that for a while. I think it'd be really cool. But we don't have it yet. What is the max voltage that you can measure? That depends on a number of things. That was asked by Dominic Matic. The maximum voltage you can measure really depends scope to scope. It's in the data sheet. And usually there's a peak-to-peak rating, which is peak to peak. And then there's an RMS rating, so you have to watch out for both of those. The other thing you can do if you're trying to measure high voltage is use a high voltage probe. So I'm just going to pick a number because I don't remember what the input is for this one, but say it's 200 volts peak to peak. That's at the BNC input. So if you're using a 10-to-1 probe on 200 volts, you're only sending 20 volts into the scope. So you can actually, if you're able to put 200 volts peak to peak max into the front end of a BNC and use a 10-to-1 probe, you could actually hook it up to 2,000 volts, which safety concerns and all that, but just as an example, the attenuation part of your probe matters, and that's why you see on like high power differential probes those like 100-to-1 or 1,000-to-1 attenuation ratios on your probes. Here's a question from Mohammed Assam. What is the Keysight ADC sample frequency and bandwidth relation rule of thumb? So in theory, based on Nyquist, you could measure a sine wave, a 100 megahertz sine wave at 200 megasamples a second, so you basically double it. In practice, when the rubber hits the road, you really need about 2.5 times that, the maximum bandwidth you're trying to measure, and that's only for sine waves. So if you're measuring square waves, there's higher frequency components. We actually just talked about that in a recent video, like covering bandwidth and how to measure higher frequencies on your scope than the actual rated bandwidth of the scope. But 2.5 is generally a minimum, and that's why you see like 2.5 gigahertz. 2.5 gigasamples a second on a 1 gigahertz oscilloscope. Sometimes we go higher up. I'm looking at that to see what that sample rate was. It's 5. So usually, in any respectable, reputable scope manufacturer is not going to let you have a sample rate that's too low, like by default, until you start to go to a longer time per division. You start to use more memory, and then it'll have to tank the sample rate just to fit all the samples into memory. So that's where you'd have to be careful with that. What else? The fan. Someone says another vendor, I'm not going to say the name, doesn't really inspire a low fan volume. It's not too bad on the 1000. Some of the other ones, one of the things is as you add more electronics and get to higher bandwidths, the system is generating more heat, so you need more fan power to mitigate that heat. I have seen some people put in those. It's not recommended. I've seen it done though. Is some of those like ultra quiet PC fans and do a replacement. But it kind of, equipment, just like a computer is going to make some noise. We'll do a couple more and then call it a day. When are we going to make another bad jokes episode? People in the room, when are we going to make another bad jokes episode? I don't know. We'll have to write some more jokes. Hey, send jokes in the comments, and we'll see how they go. Someone asked, why were there no giveaways on the 2nd or 3rd of March? So the very first year of Scope Month, like in 2016, I think it was, we did giveaways on the weekends. And what that entailed was me, on Saturday morning on the couch, drawing winners and stuff. And we figured, we all work Monday to Friday pretty hard, so let's take the weekends off and come back full strength on Monday instead of trying to do weekends as well. Let's see. Do your scopes trigger on the same signal as shown on screen, for example, in high resolution acquisition mode? Yeah, so one of the things I talked about in that Spec Hack video just recently, and we'll put a link for that in the description, is that the trigger path is actually, when the signal comes in, it goes through a separate trigger path into, check out that video, but it goes through a separate path, I think, after the ADC, before the ADC, and it gets filtered, and there's also some like trigger modes you can do, so you can turn on like high frequency reject on the trigger so it doesn't trigger on noise. You can also turn on a couple other trigger modes to get better triggers. So it's the same signal, but there's the option to do some signal modification to get a cleaner, better trigger. What else? Someone says it looks like the power supply supports 400 hertz. I have no idea why it supports 400 hertz. That is a great question. We'll have to get back to you. Okay, I think we're about, someone says explain the safety, it's electrotubes again. Dave Jones does a great video on how to not blow up your scope. I highly recommend you watch that. There's some things about how you connect ground and that type of thing that you want to watch out for. It's probably out of scope of today's Q&A. My personal rule of thumb is don't be stupid, so I recommend that for you as well. Just think before you connect things, especially if you're trying to protect your thing. The count rating of the 4.5-digit multimeter is, I believe, 60,000 counts, so that's a good question. And someone else is using an old vacuum tube scope. It might be time for a new scope if you're using an old analog scope. That's all for today. Someone says 400 hertz is for planes. A couple people do Neuromod and Conrad Mueller. So awesome. I'll have to dig into that. I'm kind of curious now how we're using scopes on planes. So that's it. We're going to call it a day for today. Thank you so much for watching. Make sure to subscribe to the Keysight Labs YouTube channel. If you have more questions or you're watching this after it's live, come back on Monday, March 11th, Friday, March 15th for another live stream. We'll do Q&A at the end of those as well. And I'm Daniel Bogdanoff. Thank you for watching.